Hi, welcome back to CVEN305, our second lecture on how to evaluate structural safety. Now we are going to look at a specific example of how to do this. So let me make sure that everything is okay. So I'm going to look at an example of structural safety evaluation. Okay, so what do I want to do? I want to say, fine, I'm going to look at a sample problem. Essentially speaking, I have a wall, a vertical wall, and what I want to do is I want to hang a big searchlight off of this wall. So this is where I want to be. I want this distance to be about 3 meters. And a question is, how do I design a safe way to hang this? So I'm going to look at it and I'm going to say, okay, searchlight is a fairly big thing. It might crash and things like that. So what I'm going to do is I'm going to put a beam here from which this light hangs, and I'm going to put a support. If you look at this and if you compare it with our crane, remember this crane? It works exactly the same way. Here is the support, here is the main beam, and the weight is going to hang from there. So in a very fundamental way, hanging a searchlight off of this is very similar to hanging a big beam, okay, like in a crane. So how are we going to do this? So this is our design. So this is our configuration. And our question is, so let us label this ABC. And our question is, okay, we want to find out what should be safe dimensions. And materials. The problem with any design is that most designs work with incomplete information. So in many cases, we have to guess some data based on experience and reasonable ideas, and verify whether that will work. So in our case, so we have a number of parameters that we don't know. For example, we do not know what is this angle, how much we do. So if I know the angle, then I can calculate CB, so on and so forth. But there's always information that we don't know. Okay, there's nothing about it that we can do. So let us go through this process, and we'll see whenever there is some missing information, we will guess something. We will then check whether that will work or not. Okay, that's why I'm using Excel, because there it's very easy for you to guess and check. Okay, so step number 1 for our process is identify load. In this particular case, it is the chandelier or the searchlight. And we are going to assume it's about 200 kilograms. How do I know? I know that really big searchlights are extremely heavy. It's not just one light, there's multiple lights. And by the time you hang it all up, it's probably about 200 kilograms. So this is a heavy light. Okay, so 200 kilograms, which is approximately 2000 newtons, which is 2 kilonewtons. Okay, that's reasonable. Notice I rounded things up because I only know rough weights. So there's no point in doing very precise calculations at this stage. So we are done with this, and it's a dead load. Meaning it's not going to change with time, it's just going to hang as it is. Second, we're going to identify locations where we want to check for failure. In this particular case, we are going to say, maybe I am going to look at, it's probably going to break like this and like that. Those are my locations. So let us call it location A and B. Okay, so you can say, how would I know what locations? Well, when you are a beginner, when you start out, you don't really know what locations. What happens is, as you go and you gain more experience, you will start having very good idea where the locations are. You will get some intuition, okay, some feel. That's what it's called. So then you will know, okay, it's not going to be a problem. So as a beginner, you will try more locations than are necessary. In our case, we are going to try this location to see if that's okay. In many cases, that will allow us to calculate some parameters. Usually I want to say, okay, what determines this parameter? It's whether it's going to fail there or not. Okay, so I want to calculate there. So what I'm going to do is, now we are at step number 3. By the way, this is one of those things that that probably concerns you a little bit, because I am saying everything it depends. How come there is no answer? How come you're not telling me what to do? The answer is, there is no single way to do all of this. We are beyond the state where the only thing you have is answer at the back of the book. Imagine you are a contractor or something like that, and you're building a building, and then you decide to build a wall, and then you're saying, hey, the answer didn't match the back of the book. That's not how it's going to work. There will be several choices in front of you, and you have to pick one. Okay, so this is always the case. So get used to it. Engineering is decision making under uncertain conditions. Decision making under incomplete information and uncertain conditions. That means that you really don't know for sure whether this is the case or not. In some cases, the information may be completely missing. That's okay. That's the way it goes, but that's okay. So now we are going to do step number 3, find the forces at critical location. So I don't know whether it's obvious to you or not, but this is a truss. Can you see that? You can see that it is pin jointed. All the joints are pin joints. That's what we have assumed. And that the loads are applied only at the pin joints. So you are guaranteed that it's a truss. Okay. Since it's a truss, I am going to use the method of sections. I'm going to draw the free body diagram of this, and I'm going to carry out. So you can see where I'm doing the force analysis here. By the way, there's one fundamental assumption that we do when we do this force analysis, which is that the structure is almost rigid. Deflections are very small. See, this is actually, you already made a choice of material when you say this, because